I want to welcome everybody who has joined us on this webinar. My name is Randy Lee. I'm the Assistant General Manager for the Inland Empire Utilities Agency. I'm very excited and honored to host this webinar today for CASA. Thank you for joining us. And I want to thank our speakers, Alfredo Mihonga and from City of Manteca, and Michael Harrison from Brown and Caldwell. Alfredo's topic today is developing asset management program for wastewater and water facilities. And Michael's topic is cutting costs and reduce risk, how Roseville broke from tradition to addressing aging infrastructure. If you have any questions for the speakers or for the webinar administrator, please type them into the Zoom question box at any time. The more questions you add, the better the discussion will be. And asset management is a very important topic for CASA and CWDA and for its members. And we have a few upcoming trainings, including CASA's winter conference, which will happen in January 23rd to 25th in Palm Springs, and CWDA's annual conference will happen in April 9th through the 12th, also in Palm Springs. Please visit their website for details on these conferences. So let's get started. Asset management, why is it important for us? As we all have limited resources in our agency, ratepayers are expecting us to take good care of our assets. That's why we need to have an asset management program. The asset management program is hard work, but it's critically important for utility like us. It's also very important for us to communicate that to our stakeholders and ratepayers, what we're doing with their hard-earned tax dollars. And it's difficult for the ratepayer if the only time they see us out there is fixing pipes and leaky water pipes. So communication, public outreach, and messaging is really important. On top of this, we also have lots of retirements, lots of institutional knowledge is going out the door, but at the same time, we bring fresh new blood into our agency. Our job as utility managers, we provide public service while managing risk. In asset management world, our task basically is to extend the life of our asset as long as possible based on the appropriate criticality analysis of the equipment. And one of the most important asset management for IUA, Inland Empire Utility Agency, is having the right philosophy and making sure that philosophy is communicated throughout our organization, all the way from our general manager down to the line level staff. And asset management doesn't just happen in operations and maintenance. It needs to be throughout the entire agency. From engineering has to design the right project, fits the purpose, the right equipment, the right installation method. Construction management has to make sure they enforce those specifications, make sure the tolerances are correct when they install it, provide OEM the correct ASCO drawings, and provide the right asset registry to the maintenance department. Once maintenance gets handed over the asset, making sure that maintenance department provides the right execution plan for the asset. For IUA, we actually develop and implement a program called Reliability Center Maintenance. Any questions regarding that, you can always, Without further ado, I'm going to turn this over to our speakers. As I mentioned earlier, our first speaker is Alfredo. He works for the City of Manteca's Public Works Engineering Division, and he leads the asset management program for them. He has 15 years of civil engineering experience. He is the city's CMMS administrator and oversees the GIS and CMMS applications. Alfredo is a graduate of San Francisco State University. Again, Alfredo's topic today is developing asset management plan for wastewater and water facilities. Alfredo, please go ahead. And oh, by the way, for participants in the webinar, please type in your questions and I will read it to Alfredo at the end of this brief. Alfredo, go ahead.
Welcome everybody to developing an asset management program for wastewater and water facilities. I want to share my experience on how an asset management program was developed for public works facilities. The city's wastewater control facility, or known as WQCF for short, it's a 12 million gallon per day plant. Over the years, the plant has gone through several upgrades. Currently, 2 new digesters and a CNG facility are being constructed. Here's a view of one of the digesters being built, along with the surrounding CNG facility. The water, sewer, and storm systems of the city are composed of 300 miles of water lines, 250 miles of sewer lines, 250 miles of storm lines, 80 storm stations, 20 wastewater stations, and 19 potable water wells. A large part of these assets have been entered into our asset management program. The agenda topics that I will cover today are asset management lifecycle, asset hierarchy, asset naming standard, computerized maintenance management system, also known as CMMS. I know some of you may be thinking, why do I need this? You need it if a regulatory agency may need to see maintenance records during an audit or a violation. Complex equipment is becoming harder to maintain. Currently, you're running your facility in a reactive maintenance mode, or paper work orders make it hard to schedule work or generate a report. If you apply this, the facility will run in a more proactive maintenance mode while reducing the reactive maintenance. An asset management program will be the repository center for maintenance, planning, scheduling, and reporting of work orders. Now I will talk about the asset management lifecycle. How I began my journey for the Public Works Asset Management Program was after the CMMS was newly installed. I was asked to administer the program, but having a CMMS software does not mean an asset management program exists. CMMS is just a portion of the program. The goal was to launch the CMMS software for the department use. So I took the software from test servers to the production servers. Initially, CMMS was slowly adapted by staff, and I got comments from staff that the CMMS was having problems. From my background in software development, I started to look at the life cycle process of the asset management program and found that some of the steps were not clearly defined. The asset management life cycle consists of the following steps. Step 1, concept. This is the planning or the business solution. Step 2, design. Here, business logic and physical logic is developed. Step 3, development. This is where the project is built, software is installed, data is gathered and entered. Step 4, operations. Now you launch the project and you get staff to start using it. Next, step 5, audit. Here you review and check how the project is running and performing. And based on comments from staff, modifications are made where needed. I looked at each step and discovered the following. In step 1, the concept, the business solution was to get a work order management system. This was the CMMS software. So that was done, but realized there was not enough staff to run the program. In this case, it was just me. In step 2, design, the business logic and physical logic was not fully developed. As I discovered by talking to staff who was using the CMMS, the asset hierarchy was not easy to navigate and it was not complete. The naming convention created for this program added to another existing naming convention. The design of the work orders was too generic and the job steps were not clearly written. Next, in step 3 development, the program suffered from the incompleteness of the design and the database. When the CMMS was initially launched for staff to use, all the program flaws made the operation of the CMMS difficult and frustrated users. A proposed solution was to substitute the program with another CMMS software by a different vendor. I saw that another CMMS was not going to fix the problem. Instead, the lifecycle process needed to be redone. And this was made possible with the support from department leaders and getting more staff to help build the CMMS, run the asset management program, and support the software. I started in step 2 design by developing the asset hierarchy. Here we organized the public works facilities into categories. Having meetings with staff for input created the current hierarchy. The goal was to set up the hierarchy in a way that fit our organization. Here's a closer look at a portion of the asset hierarchy with the categories and subcategories labeled. We broke down the WQCF hierarchy into plant process and gave each a number. For example, item 6, disinfection. In it, you'll find the UV system. Or item 7, solids treatment. In it, you will find the digesters. This hierarchy best fits our facility and it's easier to use. In the design, all assets are identified with their attributes. This information comes from staff interviews, and we only import attributes that are created for each piece of equipment. This view shows the lowest level of the asset hierarchy. You can see individual assets such as a grinder pump. What follows the asset hierarchy is the asset naming standard. Most facilities will have a naming standard that identifies a piece of equipment, also known as an asset ID. If you have one, then use it for your asset management program. The naming standard needs to be unique for every asset, and it must be able to grow when new equipment is added. The facility should only have one naming standard. In our case, when the CMMS was initially launched, the software generated a new naming standard, so we ended up with 3 asset IDs. One for field equipment nameplates, one for SCADA graphic labels, and another one for the asset hierarchy that was created. So one piece of equipment could have 3 asset IDs. The goal was to develop one asset naming standard for the facility. And again, this development needed involvement of staff, and the naming standard needs to fit your facility. This is the asset naming standard being used at WQCF. It is composed of 6 segments. The asset name acts like an address. From the information, staff can determine the approximate process area of the equipment. Here, in this example, item 1, the WQCF, is the facility location. Item 2, solids treatment, is the system location. Item 3, digester, is the process. Item 4, asset type, is the pump. Item 5 is the system code that refers back to the solids treatment. And item 6 is the sequential number of the pump. For the instrument loop diagrams and piping instrumentation diagrams, the ISA naming standard was used. We selected this naming standard because design engineers, instrument technicians, and SCADA programmers are familiar with the ISA standard. This portion of a drawing is from a portable water well facility that is being currently designed. Here you could see the ISA naming standards symbolized with a circle, and the city's asset six-segment naming standards, which are the long rectangular with the labels inside. Here are some photos of equipment field nameplates. Here we're showing a pump for the fog system, and next to it is a breaker for a digester compressor. This is the main view of the CMMS software for Public Works. The software is the main interface for the users and the asset management staff. If you don't have this software, then it should be selected during the design step, because the major requirements of the CMMS will be developed in design, and with those requirements, a product could be selected. The CMMS Public Works is using was reevaluated during the asset management lifecycle. The results came back that the CMMS met our requirements, so we kept the software. Listed here are some common CMMS programs available. Public Works is using ViewWorks, but there's also CityWorks, Cartograph, and Maximo. All of these programs use an enterprise-level relational database to store the information. There's no perfect CMMS. All are going to have some flaws, such as too many menus to navigate, or it's hard to customize the work order or the program view, or there's no GIS connectivity to display maps, and some are just specialized for building maintenance only. The software is needed before you could go to step 3, which is the development. During development phase, the asset hierarchy is created based on the design. All the process containers, equipment, attributes, and data are entered into the CMMS by the asset management staff. We found out that the development phase will require a lot of data gathering and data input. Also, during the development phase, the work orders are designed and created. A work order design reflects the information maintenance staff and management want to store. Then the work orders are entered into the CMMS database by the asset management team. Here's another view of a work order. This is the work order job steps that are also created during development phase. All the job steps were developed by having discussions with maintenance staff and doing research on O&M manuals. This is another detail that takes a lot of time and research to develop and put together. And again, this will help out the maintenance staff on completing their job. Next is the scheduling setup for preventive work orders. The software will generate work orders at a specific date in the future once the schedule is set. Here, the red highlight shows the scheduling portion of the CMMS, and then the yellow circle or highlight shows the history for that particular work order and what's pending in the future. After setting the work order schedule, now the CMMS is ready to generate work orders, which then moves us into step number 4, operation. In the operation phase, the CMMS is launched for staff to use, so now your asset management program is now started to run. Following is a work order that will be filled out by maintenance staff. The red circles highlight the areas of input from that staff will put in. After the asset management program has been operating for some time, the work order history will be developed. Here we're looking at the asset hierarchy for a piece of equipment, which is highlighted in the red, and next to it in the yellow highlight is the work order history for that piece of equipment. This is one of several views in the CMMS program where information can be viewed quickly, and also individual work orders can be opened up and see what they contain. Being able to quickly pull up the information on equipment without having to go through paper documents is a main feature of the CMMS. This table shows the work order activities from the most recent to the oldest. This is another way to view the facility work order history and be able to generate a report on the work that is being done. The table columns that are listed here are 1, the work order ID, 2, the status, 3, log by, log date, location, activity, and department. The CMMS feature is to be able to quickly look up work orders and to store and track the work orders for all the departments that are using the CMMS. After running the program for some time, step number 5, the audit must be performed, or where quality control is done. Here, system bugs are found and comments from staff are collected. We want to incorporate the comments to improve the program. An asset management program is a living project that needs to be audited for improvement. In closing, asset management lifecycle, asset hierarchy, asset maintenance standard, and the CMMS software all compose an asset management program. Where is Public Works today with the program? I have posted here some statistics of what has been included into our asset management program. We have 800 miles of wet utilities, 3,500 assets, 80 storm stations, 20 wastewater stations, 27,000 work orders are currently stored in the CMMS, and the future development of adding 19 potable water wells will be done. Thank you for your attention. Any questions?
Great, Alfredo. As I mentioned before, please, if you have any questions, post it on the Q&A panel, the box. I haven't seen any yet, but I do have a question for Alfredo. It sounds like you guys gone through a lot of effort getting the CMMS in place. Do you guys have a planning module that's already in place, or in the future you might purchase a planning module for the CMMS?
So when you're saying a planning module, is it a scheduling module?
Maybe a scheduling module.
Yeah, the scheduling module is included in this product. So that's standard with the CMMS.
Are you using it?
Yeah.
Okay, great.
Yeah, we're using it for our preventative maintenance work orders, and we basically set the frequency, and once we set them, they'll be generated.
Okay. All right.
Randy, this is Alec from headquarters, the administrator. You've received a question.
Okay, I got it right here. How long did it take CMMS to implement?
So that's a very good question. To get it to this point, we've been at it for at least 5 years. 5 years to get it to the point that we're at right now. And we're still developing it because as the system grows and the city and all the assets grows, we still need to tweak the CMMS.
Alfredo, how long did it, follow up onto this question, how long did it take you to become proficient at CMMS?
Oh, so that's good. I mean, this is why I wanted to put this presentation, because I wanted to share my experiences, because at the beginning, I was a novice at it, but it's along that 5 years process, I've become and gaining more experience and becoming proficient. I still feel I have a lot to learn, and so my development's still happening.
Okay, all right. Any other questions?
Randy, they're appearing in the chat window, which is just fine, but
okay.
If folks can add them to the Q&A window, the chat will work, but there are some in the chat.
Okay. Okay. One question. How long did you manage your piping infrastructure on the plant side in your asset registry? One asset for piping system like free water? How many assets for piping system? If so, how did you decide how to parse the pipe segment as assets?
So I'm trying to, can you repeat that question? Is it talking about the piping in the plant?
Yes. And how do you separate them from section to section?
So the piping that we have in the plant, there's basically the maintenance on it. It can't get to it unless it fails and it bursts. So we have to open up the ground. So what our assets, we're not including some of the piping or most of the piping, but we're including the physical assets that our crews can actually walk to or are located in vaults. So we broke down the plant into zones and developed boundaries. And each boundary, then those assets will be placed into the hierarchy.
Another question for you, Alfredo, is what CMMS program are you using?
We're using ViewWorks.
Okay. All right. Have you been able to measure positive impact on your budget or ROI?
That right now is still being determined. Our main goal was to develop the CMMS that fits our facility and start using it. So that's our next goal.
All right, great. With the time constraint, I think we have to move on to the next presentation. Thank you, Alfredo. That was a great presentation. Next, we have Michael Harrison. And Michael is Sacramento Wastewater Department Manager for Brown and Caldwell. And he has a number of projects. He's a member of the project team that worked on the $1.6 billion cold water program. He also led a $40 million side stream treatment research project, which is now under construction. He's a graduate of UC Davis and holds a master's in civil engineering from Cal State Sacramento. And I'm gonna turn it to you now, Michael.
Thanks, Randy. It's my pleasure to present this. As the title slide shows, I did this at WWTP, myself and Jason Fick, who's a chief plant operator at Roseville. So I'll kind of put a twist on this. It's not specifically related to asset management, but we used asset management principles to determine risk to figure out how to do our condition assessment. So the agenda would be talk a little bit about the background of Roseville, if you're not familiar with it, where it is. I'll go through the approach that we used for our condition assessment, and then present some inspection results, and then close it out with some surprises and lessons learned. So City of Roseville, if you're not familiar where it's located, most of your California, so it's near Sacramento, a little bit east. The city owns 2 wastewater treatment plants. One's Dry Creek Wastewater Treatment Plant. The other one is Pleasant Grove. They're a regional facility, so in addition to Roseville, they provide wastewater service to other towns, Loomis and Rockland, and unincorporated Placer County. So the first treatment plant is Dry Creek Wastewater Treatment Plant. It's the older of the 2 wastewater treatment plants. It was originally constructed in the 70s. It has been expanded over several years in various phases and has a lot of facilities there. This is the one that requires the most inspection to see how things are going. And Pleasant Grove is the newer plant, constructed in 2004. So this treatment plant was really constructed to serve the new future growth in the Roseville area. It's a rapidly expanding area, and this one was designed to expand out and is the newer of the facilities. It's currently going under a design to add digesters, primary clarifier, and a vehicle fueling system using digester gas, cleaning it and using it for a compressed natural gas filling. So it's going through a lot of projects right now.
Michael, this is Alec. If you can move closer to your microphone.
Okay, thank you. I'm hoping that I'm speaking in the right direction. So thanks. I'll try to be as loud as I can for you to see and hear. Project drivers. The city actually collects funds. They have a replacement planning module that actually collects rehabilitation funds. They don't really specifically identify projects, but they collect the money based on the replacement planning model. So they were really looking at specific projects that they can put their money to help with the rehab program. They also had limited understanding with the buried and submerged infrastructure at their wastewater treatment plants. They really didn't have any idea of the condition, but they did have a really good understanding of all the smaller assets, and they had a good, they used Maximo for their maintenance management system. So they have a good understanding of their small assets, but no real good indication of what the condition is for basins and buried pipe. So they really wanted to, as it says, buried infrastructure time bombs, they wanted to fuse those. They were very concerned with it. So that was why the driver of the project to do a condition assessment. Challenges, it's very expensive to really do a physical condition assessment. It's a very lengthy, complicated process if you really go into the details of looking at all your buried infrastructures. You need specialty subcontractors, special subject matter experts to really go into the detail on the concrete and the steel. It involves major shutdowns. You need a general contractor to help do with the work. There's lots of different inspection technologies. So it's really, what do we use and where do we apply it? And actually collecting useful information that they could use to really help them manage their aging assets. So those were the challenges. And we were on board to really start the process. And what we decided to do was use a risk-based condition assessment process. And you all maybe have seen this type of chart, but it's really 2 factors: likelihood of failure, and that's what the condition assessment will help define, and consequence of failure. Consequence of failures at the plant was fairly well known because they went through a process to look at criticality with a lot of their assets. So we use this as a springboard to develop our process to do a condition assessment. And this figure shows really our 3-step, 3-level process of doing the condition assessment. And I'll kind of talk you through what it was. You'll see dollar signs on the left as you go down. On the top is all the assets that we were looking at and what we did. The first level is level 1, and that's really looking at all the data. Looking at the age of the assets, theoretical useful life based on ages, materials. We looked at maintenance history of larger facilities on the plants to determine, they're doing a lot of maintenance or not on the major facilities. And at that point, we could screen it out. And we actually evaluated the assets by determining a total risk score based on likelihood and consequence of failure. The likelihood of failure at this point is theoretical. We haven't looked at the facilities, but the plan was to do level 1 if there's any obvious replacements, we would identify it then and go to the next level, which is level 2. Now, this is more expensive. It requires subject matter experts to go out in the field to actually visually look at all the facilities. And again, once we go out on site, they would assess the condition, reassign a likelihood of failure score, and screen it out. And then the final level was the physical condition assessment. Now, this level is essentially done by specialties. They take concrete core samples, they shut down the plant, they take coupons of steel and conduct a real detailed assessment. As you can tell, the funnel gets narrower as you go down, and that's because we'd like to prioritize the facilities and assets that we looked at for each level to really make this process cost effective for the client. We basically wanted to work to whatever their available budget was to determine all the future facilities that need to be rehabbed. This is another step on the process, and as you can see on the figure, when we did the level 1 desktop analysis, the number of assets was increased. I was a little concerned as the project manager how to get this project done if there was more things to look at. But what it is once you look at your facilities and figure out what you want to look at, it brought up more questions with the staff that we should probably look at more things. So we actually increased the number of assets that we conducted under level 2 analysis. And this was a snapshot of level 2. So what we did is we collected information in level 1. We created an asset registry of all the assets, grouped them under the structures and areas, and then prepared a database from their Maximo to create a mobile data collection for our field verification and field visual inspection. We used a software called Fulcrum. There's tons of different types of software to use, but really our subject matter experts went on site. They were armed with an iPad with the Fulcrum system so they could easily collect information on the visual condition of all the assets. And you'll see a picture of one of our staff there. It was a really good system. We were able to do this very efficiently. It's all a great photo and file management with this system, and really it was a good cost-effective way for us to collect information on all the assets on a visual basis. Level 2 results. So what we tried to do at this point was we looked at the condition of the facilities, all the things that we were looking at both plants, and we would revise the likelihood of failure scores, which would revise the overall risk score. We confirmed what assets we wanted to do level 3 inspections on. At this point, we also identified RRR, or rehab, repair, replacement projects based on our visual inspections. And we also identified minor repairs. So we've gone through level 1, level 2, we've prioritized assets, and we're continuing on now with level 3. As we go, we build this database. This is a clip of condition scores and information that we collected that would be in a database. So level 3 was our large part of our project, and it involved a series of folks, including Brown and Caldwell, the city of Roseville. We had Boss Labs, which did the concrete evaluation and inspection. We had Blackstone Group that did the metals. They evaluated the metals and steel. And we had a firm, National Plant Services, that actually helped do the television, basically inspecting CCTV, all the areas that we needed to look at. And finally, Auburn Constructors was the general contractor that we used for the process. So this is a snapshot on the upper right of a 3-week look-ahead schedule, but this was a very intensive part of the work.
Michael, it's Alec again. If you could adjust your microphone once more, it just switched to faded out.
Okay, so I apologize to the group. I'm screaming into my computer, so hopefully it's clear.
Clear.
Okay, keep continuing. So the duration of this process, this phase of the work was 7 weeks. We did inspections, physical inspections at both wastewater treatment plants, and it really required some pre-planning to coordinate. As you can imagine, we have several different subs running all over the treatment plant, and we needed to coordinate the activities to make sure we can get it all done in our period of time. We actually used lots of city operations staff. We used collections crew. And we basically planned shutdowns and bypasses throughout the plant to really be able to inspect some of the things that they never really could really take a look at. So it's a very comprehensive process. So I wanted to show you some examples of what we came up with in our inspections over the next few slides. This first one that I'm showing is the Influent pipeline, and this was really the biggest surprise. I mentioned earlier that they wanted to eliminate the surprises and diffuse time bombs. Well, this is an example of one inspection that we did that really indicated they had some really aggressive corrosion and loss of concrete pipe. What you see on the right is the crown of the pipe with the reinforcement bar exposed. So that tells you right away they've lost quite a bit of concrete on this pipe. Originally, it was supposed to be a T-locked PVC line pipe that really wasn't. So we were able to, in our inspection, this section of pipe was inspected and saw this. So we've immediately recommended a replacement repair on this pipe section, which is in the process of happening right now. This was very good to see. We were relieved. Part of us was relieved that we saw it, but of course the city was a little concerned about this. So they actually put a large plate on top of this Influent pipe just to protect it until they could repair it. This is another example of an effluent pipeline. So this is the Influent pump station effluent pipeline. This is conveying raw sewage from the pump station to the screens and headworks. We were not able to actually inspect the inside of this pipe, so we were unable to drain it based on the configuration. So this one, we actually went on the outside. We chipped away the concrete and did the inspection from the outside using our metals specialist. So we looked at the outside to determine the thickness and corrosion of the pipe. And this one actually was good news. The pipe was in really good shape. And so we basically said for this one to continue to operate, maintain, and monitor. All right, here's another example of the grid influent channel. And one thing I failed to show is that there is a risk score you'll see on the top of each of these slides. And that's a function of the likelihood and consequence of failure that we determined. And that would basically rank the projects in the end when we get to the end, and I'll show you the printout of that. This influent channel was one that was basically not operating correctly. When we tried to drain the channel, they had to empty it with 10 Vector loads. It was filled up almost to the top, and they really weren't aware of that. What happened was the diffusers, air was used to mix and keep things suspended, and the materials clogged that up and became settled and filled up the basin at this point. This is upstream of the grid channel. And one of the interesting things about this grid influent channels is that we actually modified their maintenance practices here. So we'll do a replacement modification, but we'll defer that. And in lieu of that, for a while, they can actually just conduct more aggressive maintenance, which is really going to be factoring out the influent channel at a frequent period of time. So this is another example of changing some maintenance practices to actually prolong the life of the assets. This is the primary sedimentation basins, and this is the one where we actually took the basin out of service and actually did concrete core samples and sounded the concrete to figure out the thickness and the condition of the concrete. This one wasn't a surprise. This is the older primary sed basins. We did recommend replacement, but not a short-term, but more of a long-term replacement. And a rehabilitation for this. So the RR would be a rehab of the concrete. The cover over the rebar was around 2 inches. That's what we determined. The low strength concrete was determined at 4,800. A little bit of scaling, but this was just an example of using the concrete specialist to really make a decision on how long the concrete is going to last. This is the tertiary filter system. And what we tried to do here is the city was interested in looking at the condition of the under drain. They asked someone else to take a look at it, and they were perplexed as to how to do that. But we were able to run a camera in an access hatch underneath the under drain to get a snapshot of the condition. So you'll see a picture looking up at the nozzles. And actually the condition was surprisingly pretty good for considering the age of the concrete here. So we were able to recommend just to continue to operate, maintain, and monitor for this one. This is a summary of all the projects. I talked about a few, but this is really the heat map that we generated based on the risk scores. So you'll see on the, this chart on the upper right is really the high priority projects that should be done first. And it's no surprise that we have the Influent pipeline there. And as you go down to the left, it's lower priority projects that need to be done. So this is a really good tool to really prioritize your projects, basically using the data, likelihood of failure and consequence of failure. So this is Dry Creek. And I'll give a couple examples of Pleasant Grove as for the next project. So Pleasant Grove was a little bit easier to do because it was a newer facility, but this was an interesting story. We did a level 2 evaluation of these secondary clarifiers, and it seemed like it was an imminent means of falling apart right away based on our visual inspection. But upon further evaluation of level 3, even though it looks really bad, they still had a little bit of life in this system. So you'll see crusted, corroded metal, but in reality, there was plenty of metal left. So there's a replacement project for this, but we were able to, based on our level 3 evaluation, put off the actual project for a few years to really extend the life of this as much as we could. This is an example of the tertiary filters. The city was not happy with the operation of these filters. These filters are continuous backwash filters by Dynasand. And what we did here for the evaluation was to simply remove the sand and actually just physically inspect one of the filter cells to see the condition. And actually, it was bad news for the city. They were hoping to find some problems because they really didn't like the way these filters operated. But in reality, they were in really good condition in the structure. So we basically just recommended continue to operate, maintain on this one. And here's another example of the heat map. So this one is for Pleasant Grove. Same concept. The upper right are the clarifier mechanisms. That's the highest priority, but it's not quite as urgent as the other projects at Dry Creek. But we identified 5 projects that really were defined projects they needed to do over time. And this heat map was a very useful tool to help prioritize and was very helpful just to develop our capital plan. What we needed to do from here is actually define projects for the city with some timing. And that's what we did here. The way we did this was we grouped some of the major projects or assets into projects. We completed construction cost estimates for whatever we're going to do there, if it's a rehab or replacement, and then worked with the city to develop the implementation schedule. And we used the risk score that you saw on the heat map to really figure out the priority of what needs to be replaced first. And we did something a little unique in that we used a 5-year increment. We didn't really want to get down to the nearest year when things needed to be replaced, but just an idea of when it should be. So we developed categories of 0 to 5 years, 6 to 10, and 11 to 15 as really just what facilities needed to be replaced. And as you can see on the chart, the blue represents Dry Creek, which is the older plant. As you can see, there are some projects that would be done in the next 5 years. The green would be Pleasant Grove, which is a lot smaller projects, which kind of makes sense. It's a newer plant. But this is how we completed the report that we did, is a specific plan of projects replacement and in a year time increment when to be replaced. The other thing that we actually did that we weren't done, we wanted to identify future inspections. The city didn't have unlimited money, and so we did as much inspection as we thought with the highest priority assets. Some of the assets we would like to come back, the city should come back in a few years to re-inspect based on criticality and basically condition. So we had that recommendation for them, and that's how the project was wrapped up at this point. Like any project, there's a lot of lessons learned, so I just wanted to summarize a few before I close out. So for the level 2 visual, the mobile data collection is a must. For anyone doing this, it's really an efficient way of using people's time out in the field if they can do direct data import. The other thing is to maximize the time out in the field for those folks, just to look at the site. And interviewing staff is very critical because many times there's information that's not in your asset management system that you can gain from staff interviews on condition. So that was very useful. The other thing, and I think Alfredo mentioned this, was naming convention. Having a consistent naming convention is very important. We had some numberings that were different and off that caused some confusion. So be very careful with the naming. For the level 3 physical inspections, that process, always use a local contractor familiar with the facility. It makes life easier for the staff. Make sure the treatment plant staff is engaged early, and so they can actually look and test ride some of the shutdowns. It was very instrumental for them to isolate pipes, because in reality that could happen in the future, to learn from those facilities and how it worked. Have a contingency plan for that process, allow adequate time for that type of process, and then take advantage of the shutdowns and diversions. They typically take basins out of service, so it makes sense to time your inspections when that happens. And then finally, include a repair cost allowance with the project. We did this in the event that they dig up a pipe. It really makes sense, if there is a problem, if the contractor's on site, just repair it. Don't fill it back up and plan another project. So we added a repair cost allowance that was utilized a couple times that made the project go very well. So that's really the summary of my presentation. I want to thank you for your time. And I'm going to put this screen back in the court of Randy and see if there's any questions.
All right, thank you, Michael. That was an excellent presentation. You actually recently went through a very similar inspection of our facility, and like you mentioned, we found lots of surprises. We do have a few questions that's posted by the participants. I'll start with the first one. Let's keep jumping back and forth. Let's see. Regarding your scale, how was risk score of 18 calculated for that rebar pipe, and what was the scale?
Sure. So we had a scale of basically 1 to 5 for likelihood of failure and 1 to 5 for consequence of failure. So those two numbers were basically multiplied together to get an overall risk score. And that's what we used for the basis for all the assets that we evaluated.
Okay. Another question. Could you elaborate on your construction cost estimating process?
Yeah. So what we did is, at the completion of our condition assessment, we essentially identified specific projects, and the first step was to do a repair or replacement or rehab. So once we identified if it was a rehab, we would basically create a detailed project description that we would give to our cost estimators, and they would do a level, I believe it's, don't quote me, but it's more of a higher level cost estimate. So our estimators went through and did a takeoff with some contingency. So we had quite a bit of budget to really make our estimators do this job. And there was a few back and forths, but it really wanted to give a reasonable cost estimate. The cost was construction, and then we used percentages for just project costs for admin, engineering, and all that. And then we inflated the cost depending on when they were going to build it. So for example, if it was 7 years out, we would inflate the cost by, I believe, a 2% factor to get a reasonable planning cost. So that's how we did that.
Okay, great. Next question. What was the basis for likelihood of failure in level 1 if condition was not used?
Yeah, so likelihood of failure was, we looked at theoretical useful life of all the assets. For example, if the asset was 20 years old and it was a steel pipe, we'd look at literature to figure out what would a typical lifespan be if it was in 10 years useful life. So we'd use that for the useful life. That was really the main thing that we did. We also had a factor of like conditions and factors and maintenance. So we would actually, I can probably get more detail on that, but like if they had higher maintenance costs and higher maintenance activities, we would lower the, or increase the likelihood of failure. If it was in an aggressive environment, for example, at the front of the plant, we would factor a higher likelihood of failure. So that's how we did it for the level 1 before we inspected it. And it gave a reasonable idea to start with.
All right, thank you. Another question. Could you elaborate on the Fulcrum tool, which you think, I think you said you use for collecting data in the field?
Yes, that's a good question. So Fulcrum is a kind of a commercially available software that's really a database-driven, web-based process that essentially we had someone in IT create a data collection form from the information we got from the city. So we started with the city's CMMS system and extracted the asset registries. We added columns for specific things like condition scores and observations from the people that are going to do the inspections. We also included materials and age, and we created a database form that would be accessible by anybody on site by opening it up. So it was really essentially like a database on steroids that basically created usable forms. We'd also have drop-down menus for scores. So we'd have a 1 to 5 score for condition and performance. And that's what we used out in the field. But it's pretty commercially available, and there's other software that does very similar activities. It's just our firm had some experience in runtime with that software, so we chose that one for this particular project.
All right, one last question. Could you please provide an example of how the repair cost allowance was useful and what specifically was repaired?
Sure. So in the Pleasant Grove plant, we actually inspected a grit channel. It had a T-lock liner. I didn't give that example, but that was one where there was actually some T-lock that was falling out that the contractor, we went in and said, hey, could you clean that up and actually reinstall the T-lock? So they were able to go in and do that. They also then fixed some leaks that were coming through the grit channel into the gallery. So they did some piping and sealing modifications. So even though they were just under contract to just get access, we were able to release some money for them to do some additional repairs in that example. That was the best example there. They didn't have, a lot of the condition wasn't so bad. I think we overestimated how much we thought there'd be repair, but it was really handy to have the contractor on site at that situation, and it worked out well.
All right, great. We have a couple more minutes left. Got one more question that just came in. We just started the asset management program at our plant, and I was wondering if other plants are building individual assets for all their valves. It seems like a nightmare, but valuable in the long run. Or are there any other ideas on how to add them?
So I think between me and Alfredo, I know Alfredo is very knowledgeable about assets and numbering. Maybe you can take a crack at the answer, and then I can give my take, if that works, if Alfredo's still available. If he's not.
Maybe not.
So I'll give you my experience. And again, I'm not working at the facility, but most of the facilities that I work with, they do label all the valves. And it's pretty critical. What they do many times is have a cutoff on size. So if you have a 1/2-inch isolation valve on a gauge, those aren't numbered because the gauge has a number. But there are rules of thumbs to kind of screen out some of the smaller valves that aren't critical. In another facility I used, only the motorized valves had numbers and all the manual valves didn't. But there doesn't seem to be a consistent way of doing it based on my experience with different agencies. But most of them do number their valves. It's just to the extent of that. And that's typically, when you get into that level, you need to talk with, the instrumentation tech and or Alfredo, because he's kind of the one writing the rules for the numbering.
All right, thank you. I think this is all the time we have. And I want to thank the panel, Michael and Alfredo, for participating in this important topic for us. And just a reminder that CASA has a winter conference coming up in January 23rd to 25th in Palm Springs. And CWA has its conference in April 9th to 12th in Palm Springs as well. And thank you for your participation, and we're looking forward to the next one, which will be February 14th. And the next asset management webinar will be focusing on collections. And thank you for everybody for joining us, and have a great day. Thank you.